Okay, domain and range of linear and quadratic functions. So the question was posed, how do you find the domain and range of this function here? Well, this function here, I'm not sure if it was written incorrectly, is actually just a linear function that hasn't been simplified. So these two, the very first two terms are like terms. So we're going to simplify by adding the coefficients of the two like terms. So you have y is equal to 2 and 7 is 9x plus 3. So this is now just a linear equation. The y-intercept is at positive 3, and you have a rise of 9, a run of 1, so it's a rough estimate of what it would look like is something like this, something with a very steep slope. But what's neat about linear functions is their domain and range are continuous. They go on forever. So your domain for this would be x is the element of all real numbers, okay? And your range for your linear function would be y is the element of all real numbers. Sorry, my calligraphy, I guess that's the word, is not so clear right now. But let's say that this question was actually y equals 2x squared plus 7x plus 3. Well, that's very, very different. This is now a quadratic function. So that means it has something like this, where it still has a y-intercept of 3, but we don't know which side it's on. We know it's heading upwards. This is a bit different, okay? With quadratic, the domain is still the same, okay? So we don't have to do any calculating or anything. This is technically in what's called standard form. So it's a little hard to tell our important information. The important information for the domain and range is going to be where the vertex to the quadratic is. But like I said, the domain, still straightforward like a linear function. The domain is still x is the element of all real numbers. The range, however, is continuous, and because it's a continuous function, we started off with y is the element of all real numbers, but it does have a restriction. Because the a value is positive, we know that it is opening upwards, like I've drawn. So y is going to be greater than and equal to some value. And that value is dependent on where the vertex to this is. Now, we could find the vertex by putting in completing the square, or maybe factoring it, find x-intercepts, and then find axis of symmetry. There's a lot of different methods. Because we're just looking at domain and range, I'm going to quickly just type this function into a graphing calculator so we can quickly tell where the vertex is. So 2x squared. So here we are. We have 2x squared plus 7x plus 3, I think it was. There we go. Like I said, our y-intercept is still 3. We have our two x-intercepts and our y value, okay? So the y value, negative 3.125. So what that means is the lowest point here is negative 3.125. So y is going to be greater than and equal to, and greater than because it goes above, okay? Negative 3.125. So that's the only restriction on the range. It's going to go above that. And you'll notice again for the linear function, I'll type it in just so you can see, I think it ended up being 9x plus 3. You go forever, and it continues forever. So you notice the quadratic function goes upwards and left and right forever, but doesn't go down. The lowest point is negative 3.125, and the domain and range for the linear is continuous. It never, ever stops.